Hey everyone and welcome. So, have you ever wondered what people actually mean when they say they code? Or how the apps on your phone really work? Well, if you have, you are in exactly the right place. Today, we're going to pull back the curtain on the whole world of programming, and we'll be using one of the most beginner-friendly languages out there to do it, Python. All right, let's dive in. But first, let's start with a really big idea. Think about your computer or your phone. It's just a piece of hardware, right? It's a bunch of plastic and metal and silicon. So what is it that gives it life? What makes it useful? That brings us to this question. Why do people say software is the soul of a computer? In so many ways, it's absolutely true. The hardware, that's the body. But the software, well, that's what gives the body a purpose, a personality, and the power to do all kinds of incredible things. Seriously, without software, your laptop is just a very, very expensive paperweight. It's the programs that let us connect with people, create art, and figure out complex problems. And that's exactly where programming comes into the picture. At its very heart, programming is just the act of giving a computer a list of instructions. It's really a form of communication. It's our way of telling this machine precisely what we want it to do, one step at a time. We're the ones who get to be the architects of that digital soul.
Now, I really want this image to stick with you. A lot of people have this idea that programming is some kind of magical talent that you're just born with. Let me tell you, it's not. Learning to code is way more like learning to play an instrument, like the piano. You don't just sit down on day one and play a masterpiece, right? No! You learn the notes, you practice your scales, and piece by piece, you build that skill over time.
Okay, so if programming is all about giving instructions, we've kind of hit our first big problem. Just like music has its own language of notes and chords, we have to find a language that the computer can actually understand.
And that right there is the fundamental challenge. Because deep down, at its most basic level, a computer only understands two things, on and off. That's it. We just represent those states with ones and zeros. So the big question is, how in the world do we bridge that massive gap between our complex human ideas and that super simple binary language?
Think about it for a second. Our language is just filled with nuance and sarcasm and context. If you say to a friend, "Wow, it's a little chilly in here," they get the hint. They know you probably want to close a window. A computer, it would just store that as a fact. It needs absolute, total precision. There is zero room for confusion in the world of ones and zeros.
So what's the solution? Well, it's a translator. We write our instructions in a language that we can actually read and make sense of. We call that source code. And then a special program, which is called either a compiler or an interpreter, takes our code and translates it all into those binary instructions that the machine can finally execute.
Now here's what's so cool about this. Programming languages exist on a whole spectrum. Way down at the bottom, you've got these low-level languages. They're super close to the machine's native ones and zeros. They're incredibly fast, but they are a real headache to write in. But way up at the top, you have high-level languages, which are much closer to human language, and that makes them way easier for us to use. And that brings us perfectly to our tool of choice for this explainer, a super popular, incredibly powerful, high-level language called Python. So why Python? What's the big deal? Well, first off, like we just said, it's high level. Reading and writing Python code honestly feels more like reading plain English than it does some kind of cryptic machine language. It's also general purpose, which just means it's not a one-trick pony. You can build pretty much anything with it. And most importantly for us, it's famous for being one of the easiest languages to learn, period. And believe me, when I say you can build anything, I really mean it. Python is the engine behind huge websites. It's the #1 language for data scientists trying to make sense of massive amounts of information. It powers so much of today's artificial intelligence and machine learning. You can even use it for something as simple as automating the boring, repetitive tasks in your own life. And look, this isn't just some language you learn in a classroom and never see again. Python is a total workhorse of the modern internet. Major parts of the apps and services you use every single day, think Instagram, YouTube, Dropbox, they were all built using Python. So its power is literally all around you. Okay, so now that we've got that foundation, let's look at the absolute basic vocabulary of Python. Think of these as the fundamental nuts and bolts of every single program you'll ever write. First up is the variable, and this is probably the single most important concept in all of programming. All a variable is a name you make up to store a piece of information. The best way to think about it is like a box with a label on it. You can put something inside the box, and whenever you need that thing, you just call it by its label. This is a perfect example. On that first line, all we're saying is, "Hey computer, make a box for me, slap the label X on it, and put the number 5 inside."
Then, on the second line, we do it again. Create a box labeled Y and store the number 6.6. It is truly that simple. From now on, we can just use X and Y to talk about those numbers.
But, we need to store a lot more than just numbers. What about text? Well, for that, we use something called a string. And a string is just a sequence of characters. Could be letters, numbers, punctuation, pretty much anything you can type on a keyboard. It's how we work with words and sentences in our code. And making a string is super easy. You just wrap your text in either single quotes or double quotes. It doesn't matter which. So in this example, we're taking the text Charlie and we're storing it inside a variable, inside a labeled box that we've decided to call name.
So, once we've got our data stored away in these variables, we can actually start doing useful stuff with them. For instance, if you've got numbers stored in variables like X and Y, you can add them, subtract them, whatever, just like you would on a normal calculator. The computer just looks inside the boxes, grabs the numbers, and does the math for you.
So we've seen variables for numbers and variables for text. Now let's see what happens when we put these simple little blocks together to create a tiny but totally complete program. Okay, take a look at this. In those first 3 lines, we're just creating variables, our labeled boxes, to store how many quarters, nickels, and dimes we have. Simple enough. Then, we create a new variable called total change, and we tell the computer how to figure out its value. Take the number of quarters and multiply it by 0.25, then add the number of nickels times 0.05, and so on. And finally, the program tells us the result, $2.75. And just like that, you've understood your very first program. It uses variables, it uses numbers, it uses arithmetic. That's the programming equivalent of learning your first few notes on the piano. These simple, fundamental pieces are what all those massive, complex apps are built from.
You see, the secret isn't some kind of magic, and it's definitely not about being a genius. The key for both the piano and for programming is just practice. That's it. The more you write these little sets of instructions, the more comfortable you'll get and the more complex and amazing things you'll be able to build.
So just remember, programming isn't some secret magical art. It's a skill. It's something anyone can learn. You've just been introduced to the very first few notes. The only question left is, what song are you going to write?